right? So we finished our unit on motion. Now forces is important because forces are the cause of motion. And so to really understand motion, we need to know what's causing them. And if we know their cause, we can better predict what's going to happen. So moving on. So forces are everywhere in nature. Right? Engineers need to consider them when they're building buildings. Sometimes if there's a force they don't consider, well, certain things happen. Also, it's very important we have forces. Without forces, our universe would not exist. I mean, due to certain forces, objects are able to stay together and keep their shape. So what exactly is a force? Well, put simply, a force is a push or a pull. Okay, forces cause objects to move, or I should say, forces cause objects to change their motion. Okay, so if you're moving, a force can bring you to a stop, or a force can make you go faster. Okay. Forces can also stretch or compress things, like if you want to think of springs, okay? Twist, distort, things like that. So we usually, when we're measuring forces, we give Isaac Newton credit for that because he did a lot of work. He's usually considered one of the fathers of physics. And so the unit for a force is a Newton. Right? And later in class, we'll experiment with exactly what a Newton feels like. I mean, if you were to try and guess, like, would a Newton would be the amount of force it requires to lift this pencil, or would it be the amount of force required to lift a car? Right? Obviously, a Newton is a new unit for everyone. So it's hard to sort of imagine exactly how much 1 Newton actually is. It's easier with things like meters. If I say this room is 10 meters long, you can imagine how long the room is. Right? But if I say this weighs 100 newtons, a little bit harder to imagine. But that's why we're going to practice next week to actually get a feeling for it. In answer to my previous question, 1 Newton would be about the force required to lift the pencil, not a car. Okay, now, in nature, there are 4 fundamental interactions, four forces that are the cause of every other force that we will eventually talk about in this course. Number 1 is the most familiar. Everyone's familiar with gravity. Okay, gravity seems to be the one everybody knows, which understandably so. Right? It's the one you feel every day. It's the one you have to fight to get up out of bed in the morning. Right? The electromagnetic force is another one. This one's everywhere, every day, which you're always encountering, but you may not really notice that it is actually the electromagnetic force. I mean, when you're standing on the ground, right, gravity is pulling you down, but you might not understand that's the electromagnetic force that's keeping you up. It's stopping you from actually falling through the floor. And then we have the strong and weak nuclear force. These have, well, nuclear, referring to the nucleus of atoms. These are the things that will help make everything possible, right? Because they are the reasons why atoms can exist at all. We won't be talking about them too much in this class, but you can think of the strong nuclear force. Oh, actually, I'll go through each one. That's what my slides are for. All right, so gravitational force. That's the attraction between all objects in the universe. Right? We can think of, say, the moon going around the Earth, causing the tides. Right? These are all gravitational forces. Okay? However, it is only an attractive force. That's different from the electromagnetic force. The electromagnetic force can attract or repel. You probably remember in grade 9 science when we do electricity, we say like charges repel, opposites attract. Right? That push or pull, that repel or attract, is the electromagnetic force when we're talking about charges, for example. But the same rules apply for magnetism. Right? Like poles, like north and north, repel, and opposite poles attract. And this is the force we actually experience daily, everywhere. Right? You try to push your hands together, right? That force you feel is the electromagnetic force. Walking on the ground, the electromagnetic force, right? Electromagnetic force really is everywhere, and it's a lot stronger than gravity is. Gravity is actually the weakest of the four forces. The only reason why you're so familiar with it is because it's acting with the entire planet. So the mass of the entire planet Earth is causing gravity to be big enough that we can feel it. But electromagnetic force you feel with atoms, things that are so small, but yet you still can feel those forces. All right, strong nuclear force. This is the one that actually holds the nucleus together. I don't know if any of you have thought about this, but in grade 9 we tell you about atoms and we say the nucleus is filled with protons. And that's what we tell you in chemistry class. And then we go to physics and electricity in grade 9 and we say like charges repel. Yeah, I wonder if anyone's ever thought, wait a minute. If like charges repel and all the charges inside of a nucleus are all positive, how does it stay together? That's the strong nuclear force. Right? And it's the strongest of the four. So it can actually overcome that repulsive force. Then we have the weak nuclear force. The weak nuclear force is due to radioactivity. This causes radioactivity. So certain changes that occur in the nucleus and sometimes cause it to shoot out radioactive elements, this is due to the weak nuclear force. Okay. So we only have one question on our handout, and we're just going to compare the relative strengths of the forces. So here's our sheet. All right, so it says from weakest to strongest. So the weakest, that's gravity. I already mentioned that gravity is extremely weak. And we can consider it, if we want to do like orders of magnitude, 10 to the minus 41. Very, very weak. Then the next weakest will be the weak nuclear. And it's on the order of 10 to the minus 16. So still very weak, but look at the differences between the two. It's a huge difference. If you don't really like thinking of exponents, remember a difference of 10 to the exponent of 6 is a millionth. And this is way more than 6, right? 41 compared to 16. Millions, 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 millions more weaker gravity is. Then we have the electromagnetic force. And it's on the order of about 10 to the minus 3. So that one's pretty strong. And of course we have the strong nuclear. And I wrote all of the other forces relative to the strong nuclear. Let's give it a strength of 1. Okay, so that's it for forces. We'll get more in detail in our later lessons. Okay, and one thing I did forget to mention is that it's very important. A force is a vector quantity. Okay, now we've analyzed vectors and scalars a lot, so it's important to know that a force has a directional property. Right? If you're applying a force on something, if you're pushing it, it's important to know in which direction you're pushing it. Okay? So that's all I'm going to mention for this lesson.